Hello everyone, welcome to 10-Minute Physiology. In today's video, we're going to be looking at what average velocity is, what average speed is, and what average acceleration is. So with that, let's give it a go. So let's start off by talking about what average velocity is. So imagine we have a car, and this car starts off at an initial position marked as 0 meters. And let's just say that this car moves from the 0 meter mark to the 10 meter mark in a straight line over the course of 2 seconds. What was the car's average velocity? Well, in order to answer that question, we need to use an equation. And this equation is given here, where the average velocity is equal to the displacement over time. Now remember that the displacement is equal to the difference between the final position of the object and the initial position of the object. So the final position of this car was 10 meters, the initial position of the car was 0 meters, and the time it took to get from the initial position to the final position was 2 seconds. Therefore, the average velocity is 5 meters per second. So the average velocity describes how fast an object changes its position. Now, the average velocity is a vector quantity. This means it has both a magnitude and a direction. Now, the average velocity vector will always point in the same direction as the displacement. So now let's change things up. So let's just say that instead of the car moving in a straight line from the 0 meter mark to the 10 meter mark, this time the car moves in a half circle. And let's just say that this car moves from the 0 meter mark to the 10 meter mark in a half circle over the same time period, 2 seconds. And if we were to map the car's movement, we see that it looks like a half circle and that the radius of this circle is 5 meters. So what was the average velocity in this case? Did it change? Well, the way to answer this question is to look at the equation. So the average velocity is equal to the displacement over time. And remember that displacement is equal to the final position minus the initial position. So the final position of the car is still 10 meters, and the initial position of the car is 0 meters, and the time it took to get from the initial position to the final position was 2 seconds. So in this case, the average velocity is still 5 meters per second. So what we see here is that even though the car changed how it got from the 0 meter mark to the 10 meter mark, where the initial way was through a straight line and this way was through a half circle, the average velocity remained the same. And the reason why is because the average velocity depends upon the displacement. And remember that displacement is a path-independent quantity. So displacement only depends upon the difference between the initial position and the final position. It doesn't matter how you got from the initial position to the final position. All that matters is the difference between the initial position and the final position. It's a path-independent quantity. So now let's practice calculating the velocity through this question here. So a car drives around in a circle with a diameter of 10 meters. The car makes one full rotation around the circle in 5 seconds. What was the car's average velocity? So take a moment, pause the video, and calculate the answer for yourself. So hopefully you took some time to calculate the answer. And when you calculated the answer, you should have got choice D. So let's explain why choice D is the correct answer. So let's start off by drawing a picture. And we'll start off by drawing our circular road. And let's just say that the car starts off at the very top of the circle. So this is the car's initial position. So after one full rotation, the car ends up back where it started. So in other words, the initial position is equal to the final position. And this is a critical fact to know in order to answer this question. So the average velocity is equal to the displacement over time. And remember that displacement is equal to the final position minus the initial position. However, what we saw here in this question is that the initial position is equal to the final position. So it's because of this that the displacement of the car is equal to 0. So 0 divided by 5 seconds is equal to 0. Therefore, the average velocity is equal to 0 meters per second. So now let's talk about what the average speed is. So let's bring in our little car again, and let's just say that this car starts off at an initial position of 0 meters. And let's just say that this car drives in a straight line to the 10 meter mark. And let's say that it did this over the course of 2 seconds. So what was the car's average speed? Well, the average speed is equal to the distance the object traveled over time. The distance that this car traveled was 10 meters, and it did so over the course of 2 seconds. So therefore, the average speed is equal to 5 meters per second. So the average speed describes the distance an object travels over time, and the average speed is a scalar quantity. So now let's change things up a bit. So let's just say that this car moves from the 0 meter mark to the 10 meter mark in a half circle motion, and it does so over the course of 2 seconds. So if we were to map this car's movement, what we would see is something like this, and this circle has a radius of around 5 meters. So what was the car's average speed? Did it change from the original average speed? Well, in order to answer that question, we have to look at this equation. So the average speed is equal to the distance over time. Now, remember that distance is a path-dependent quantity. So we have to know how the object moved from point A to point B in order to calculate it. And in this case, the car moved in a half circle motion. So in order to calculate the distance, we need to know the circumference of the full circle and divide that by 2. So in order to calculate the average speed, we use this equation here. So to calculate the circumference of the full circle, we use this equation, 2 pi times r. However, since this car moved in a half circle direction, we divide that formula by 2. So 2 goes into the denominator. So in order to get the proper equation, the simplified equation, we cancel out the 2's, giving us this equation here. So the average speed of this car is pi times r over the time. So we're going to approximate pi as 3.14, and the radius is equal to 5 meters, and the time is equal to 2 seconds. So what we get is this equation here, where the average speed is equal to 15.7 meters over 2 seconds. Now, since we're taking an MCAT, we're battling against the time. So what we're going to do is we're going to round up this 15.7 meters to 16 meters. So what we get is an approximation of the average speed as being 8 meters per second. So the approximate average speed is going to be 8 meters per second. So what we see here is that, remember, for the average velocity in this scenario was 5 meters per second. However, the average speed was 8 meters per second. And the reason why is because average speed depends upon the distance, which is path dependent. So in other words, it depends on how you got from point A to point B. Whereas the average velocity depends upon the displacement, which is path independent. This means that the velocity only depends upon the difference between the initial and final position and the time it took to get from the initial to final position. So that's why these two values are different in this case. So now let's do a practice question. A car drives around in a circle with a diameter of 10 meters. The car makes one full rotation around the circle in 5 seconds. What was the car's average speed? So take a moment, pause the video, and calculate the answer for yourself. So hopefully you answered this question. So the answer to this question is going to be A, 6.3 meters per second. So let's explain why. So to calculate the average speed, we do the distance over time. So to calculate the distance, we need to know the circumference of the road. So in this case, the circumference is equal to pi times the diameter. And when we plug in those values, we see that the average speed can be calculated by multiplying 3.14 by 10 and then dividing that value by 5 seconds. And when you do that, what you get is this particular value, 31.4 meters over 5 seconds. Now, what we're going to do is I'm going to show you a little MCAT trick. So the first thing that I'm going to do here is I'm going to look at the choices. So what we see with these answer choices is that these answer choices are pretty far apart. We have 6.3 meters per second here, 2 meters per second here, 12.6 meters per second here, and 0 meters per second here. So this means that we can round pretty liberally in our calculations here. So what I'm going to do is, in order to save time, is I'm going to round down this 31.4 meters to 30 meters. So what we get here is a much easier calculation. So what we see here is that the average speed can be approximated to around 6 meters per second. So what I'm going to do is I'm going to look at my answer choices and see which one is closest. And what we see here is that choice A is by far the closest to this approximation. So what I'm going to do is I'm going to mark down choice A. So this brings up a very important MCAT tip. In order to do well on the MCAT, you have to get comfortable with rounding. And the reason why is because the MCAT is basically a battle with the clock. You don't have much time per question, so you have to get comfortable with rounding. So one tip that I provide is that the first thing that you should do when it's a calculation-based question is to look at the answer choices. If each answer choice is very far apart, then you can know you can round pretty liberally throughout your calculations. However, you're going to have to gauge and use your own discernment in order to see how you're going to round. If the answer choices are closer together to each other, then you're going to have to round more conservatively. But the main MCAT tip here is to get comfortable with rounding. You're battling against the clock, so round when you can. So now we're going to finish off this video by describing what average acceleration is. So we can calculate average acceleration with this equation here, where the average acceleration is equal to the difference between the final velocity and the initial velocity divided by time. So in other words, the average acceleration describes how fast the velocity changes over time. So just as a quick little example here, imagine that you have a circular road. And let's just say at the very top of this road, we have a green car. And let's just say that this green car travels around the road once, so it makes one full rotation, and it does so at a constant speed of 50 miles per hour. So the question that I'm going to ask you was this car accelerating? And the answer to this question is yes. And the reason why is because the direction of the velocity vector was changing over the course of the rotation. So let's take a closer look. So let's take a look at when the car moves from this point of the road to this point of the circle. And if we were to map the car's velocity vector at a specific point in time, what we would see is that the velocity vector at this point of the circle has this direction here. So the velocity vector is going to be tangent to the circle. And if we were to move this car again, what we would see is that the velocity vector changes direction as the car moves around the circle. And because the car is changing in direction, the car must be accelerating. So this brings up a very important point. In order for an object to change direction, the object must accelerate in the new direction that it wants to move. So in other words, when the direction of the velocity vector changes, there must also be an acceleration. So acceleration causes a change in the velocity vector's direction. So even if the speed is constant, this doesn't mean that there's no acceleration. So this right here is giving you a summary of all the important points that we talked about for average velocity, average speed, and average acceleration. So I hope this video helped you understand what these three things are, and I hope to see you in the next video. Thank you for watching, and I hope to see you next time.